We come to the middle of our phase of science, and we're understanding that our movement through this is like an energy pattern. It has a frequency. And just like an energy pattern, the crests and the troughs register together as sets. And in between, the motion of the energy in its frequency has the characterization of a wave, whereas the peaks and the troughs in sets register as if they were particles. And so the universe, in its frequency of energy, actually has a pair of modes by which energy can take place. One of them is a dynamic, that is a waveform. The other is the registry of energy as particles of a specific energetic registry. We looked for the first 4 presentations in science at Einstein and his theories of relativity, specific and general, and his work with gravitation, and also with Niels Bohr and the development of quantum mechanics. And we discovered that there was a very deep difficulty originally in appreciating both Einstein and Bohr. The problem in trying to appreciate Einstein was that he mathematized his imagination so that one had to have almost a transcendent ability to have gestalts without specific elements in the visualization. Whereas in quantum mechanics, the problem was that you could not visualize it at all because you had a complete duality of wave, particle at the very same time, and it took a special transform of Niels Bohr called complementarity to be able to think of these 2 modes together. Let her come in. These 2 modes of being a dynamic was largely built around the whole phenomenon of heat. And so one of the very earliest forms of trying in early 20th century physics to understand what was happening in the dynamic of the universe was thermodynamics. Whereas the particle aspect of it was something that was only discovered. Thermodynamics came out of Isaac Newton's work 300 years before, out of the development of experiments by Faraday and by James Clerk Maxwell in England in the 19th century. But one of the deepest difficulties was the discovery of the electron in 1896. That there was something smaller than the atom, that there was a subatomic particle. Now, it wasn't called an electron initially, it was called a corpuscle. The difficulty was exacerbated the very next year by the accidental discovery by a man named Becquerel in Paris. He left some photographic paper and a sample of radium in a drawer, and when he opened the drawer to use the photographic paper, it was smudged. How could it get smudged in a closed, dark drawer? Something from the radium had impressed itself on the photographic plate, and it was the first discovery that there is radioactivity, and that obviously particles, subatomic particles, are being carried out of the atom. And so radioactivity and the electron, and very soon after that, within a year, the discovery that there is a very high energy of light called X-rays. And so all of a sudden you had subatomic particles, You had the radiation from things in nature. You had the X-rays, and the complete mystery of this, the only way that could initially be understood was by the creative imagination trying to find a new language to be able to say what you were thinking about, to be able to communicate with someone else what it is that you were understanding and seeing. And this immediately brought a problem to the forefront, which was paralleled in the world of art. And that was, one needs to have a completely new creativity of vision. And that the vision produces an art form which is prismatic, which expresses in a completely new array of possibilities various mysterious states of matter, of particles, various mysterious capacities of waves, of dynamics. And at the same time that you get the development of Impressionism and Cubism and Futurism and Surrealism, you get this rush in science headed by the genius of Einstein, who conceived of a completely new way to do mathematics, to use mathematics as an artistic, creative language. And this was already by 1905. So from 1895 to 1905, in that 10 years, it was as if the classical confidence that things were things and one could measure them and they would stay put and that they were real completely evaporated, both in the world of art and of science. And in that time period, from 1895 to just around 1905, 1906, a completely new style of teaching science was being developed in Chicago. The University of Chicago had just been founded, it was brand new. They wanted to have a world-class university, so they brought all of these creative people in together. Many of them were young geniuses. In philosophy, you had John Dewey. In science, you had George Ellery Hale, who eventually would design the Mount Palomar 200-inch telescope. You had a head of the school who kept importing geniuses like Albert Michelson, who was the first one to discover the speed of light. All of them thrown in together, and the language of creativity, because you had people in town like Frank Lloyd Wright in architecture, Louis Sullivan. All of a sudden, Chicago was like this hotbed. Let's redo education. Instead of going in the old European model or the New England model of Americans imitating the Europeans and the Europeans having imitated the Romans, who had imitated the Greeks, who had imitated the Egyptians, let's have a completely new outlook. And so one of the adjuncts at the University of Chicago was to develop an experimental high school. Because the thought was strategic, because it was creative. People who already had gone through their secondary education were already formed and had prejudicial ways of thinking, and not just thinking in terms of the mind as a structure, but the whole process of experience was already predigested. So the thought at the University of Chicago and the experimental university school in the high schools and reaching down almost to the junior high school level, let's open up the issue so that there are no walls in between subjects, in between categories, and let's take science as an exemplar for this. All through several thousand years of Western history, there was always physics is this, biology is this. They're different. And as alchemy was displaced by chemistry, now chemistry is quite different. And by the 1890s, you had this compartmentalization that the sciences were hard, they were fast, they were all distinct and different. If you majored in physics, that was it. If you majored in chemistry, that was it. Biology, different. Some of the new sciences like anthropology or archaeology, totally different. Even different kinds, so they're like social sciences. In the midst of all of this, at the University of Chicago, from 1895 to 1905, in that 10 years, as the walls of specific static thingness dissolved, they went in for teaching science as a complete array of creativity. And that the array of creativity was not based on categories of the mind, not based on structures of thought that were frozen, but it was based upon the high energy frequency of creative vision. And so the students were taught not to think in the old ways, but to explore in the ways in which artists had been exploring, and that is to go into your laboratories, into your equipment, without any predisposition, without any presumptions, and to freely experiment. What will come out? Get some kind of a glimpse, some kind of an idea, and then figure out the kind of instruments you need to build to find out about this. And don't prejudice yourself. You may have to have many different kinds of instruments before you find one that begins to show promise. And so experimental science, hands-on, began to displace the old leftover medieval scholastic Greek, Roman, European mindset that science was about learning to get instruction about what everyone knows and then testing it out and seeing for yourself that that's the way it is. The University of Chicago was extremely successful, and its science program went all over the world. And the first place that adopted it was Cornell in upstate New York. And it was at Cornell that one of our ladies that we're taking now, Barbara Mcclintock, she was born in 1902, right in the midst of all of this. She went to Cornell in 1921. She was a very odd child, and she arrived there at the time when the science program had really matured itself and was extremely creative, but one thing it had left out was women. There were hardly any women in science. It was always considered that, well, it's a man's world, because boys like to experiment. Girls like to play with dolls. Girls like to play with like little tea sets and have little social get-togethers, but boys like to find out. But Barbara Mcclintock was a very strange little girl. She did not think of herself in a gender way at all. She thought of herself as a human being who had extraordinary discovering capacities. Her mother, she said, would leave her alone on a pillow on the floor with one toy and then just forget about her. And so she learned to be extraordinarily quiet and interested in a very limited thing for indefinite periods of time, and what this elicited out of her was a peculiar quality which she had no way of identifying. There was no one around. She was born in Hartford, Connecticut. By the time she was a couple of years old, she was farmed out to her paternal grandparents in Massachusetts. Then at 6, she reunited with her family and moved to Brooklyn, New York. She had no way of knowing that she was experiencing a deep reincarnation, very similar to Tibetan lamas. And it wasn't until much later in life that she realized the things that she teased out of herself were extraordinarily like classic Vajrayana techniques. Was she a reincarnated lama? Possibly. For instance, she devised a technique of walking with her posture completely erect and in a classic yoga posture, and that when she would not walk by stepping, she would walk literally by dynamic floating forward. She didn't realize until very much later in life that this is a technique that certain spirit-running lamas use in the high Himalayas. She also discovered that when she would try to have not her mind control her body, but somehow her creativity recut her body so that the body in its kinetic awareness was transformed into a new gestalt that had a conscious dimension to it. And one of the things she tried to do was to change the temperature of her body. And she found out later that in the Vajrayana, one of the most powerful techniques was that developed by Milarepa about 1,000 years ago. Milarepa means cotton clad. And the yogic signature of someone matured in the high yoga of Milarepa is that you were given only a cotton garment to wear in the bitter cold snow. And Milarepa's monastery was Mount Everest, on the farther slopes of Mount Everest. And the graduation test was to douse that cotton garment in cold water, and then with your own yogic body heat, it's called tumo in Tibetan, to dry that cotton robe so that you would not only be warm, but you would have dried by yogic intensity the wet garment into a dry one. Hence, Milarepa means those who can do this. She was experimenting herself with this sort of thing as a little girl. Consequently, when she was farmed out to her paternal grandparents in Massachusetts, her grandfather was what we used to call a fishmonger, but he used to drive around in an old jalopy and take fish all over the place, and of course it would break down, and then he would fix it. And the young Barbara Mcclintock loved helping her grandfather fix the cars, and she learned that she could really use tools. So when she got back home at 6 in Brooklyn, New York, she said for Christmas she would like a set of tools, and they bought her a set of toy tools. And she said, no, I want real tools. I want to do things with them. So as a young girl, she began to not be interested in playing with dolls, but in playing with tools and instruments. And she discovered that she had this almost indefinite capacity to stay focused and continue and continue. And as she did, the frames of reference would penetrate into the activity so that the dynamic became more and more focused, almost like a yoga. And what would occur in that energy-focused yoga of attention was that the particality of something would get more and more fundamental. She won the Nobel Prize in 1983 for work that she had done 50 years before that no one had believed, because one of the things that she got interested in, after she graduated from high school, went to Cornell, she wanted to take a science course, and the only science course open for undergraduate women that she could take was in genetics. So she took that course. The instructor was so impressed with her that he phoned her after the course was over and said, there are no more undergraduate courses in genetics, but I'm running a graduate course, and even though you're just a beginner in university, I will permit you to come and take this graduate course. And so as a very young girl, she was only 20, she was still just a beginning undergraduate, she took a graduate seminar in genetics. And the professor was extremely impressed by her ability to go into a laboratory, to learn all of the equipment, to learn the application of that equipment, of those instruments, and to patiently proceed in such a logical way that after a very short time period, she was superior to him in lab work. And so he was busy writing one of the world's first textbooks on genetics, so he left the lab to her to be free to do whatever she wanted. And for her, it was like recess playtime. She had a whole laboratory to herself. She had all of this equipment. She had all of this tremendous interest, and suddenly she became interested in a very peculiar aspect of genetics, the gene. What are genes? What do they do? Why is it that organisms do not make copies of themselves, but they make copies of their genetic material, and that genetic material creatively plays in very special ways and releases a new being similar to the old, but not similar to an old, but similar to a pair of olds, a pair of parents, each one of which come together in a new tuning fork of creative reality, and that is transmissible. That the child now has traits of both parents, but is able to fertily interchange with another gender and produce another child, which is a creative newness. And they will have the ability to pass that on. One of the most difficult things for us in the early 21st century to appreciate is the newness in which all of this is taking place. This is one of the world-class textbooks on genes. This is the 1997 version. There is at least one beyond this, published by Oxford University Press, a world standard. He writes in the preface, with this 6th edition, almost 15 years after the first edition, so the first edition was roughly about 1983, when Barbara Mcclintock, at age 81, received the Nobel Prize for physiology or medicine. This is a commemoration of U.S. stamps that's available now. Great figures in American science. She's one of the 4. Really someone. The preface, nearly almost 15 years after the first edition, the increased maturity of the field is striking. So from 1983 to 1997, it was almost an unheard of explosion. In fact, the concept that there is a field represented by the book itself has become solid. At the time of the first edition, it seemed adventurous to combine in a single book an analysis of both prokaryotic and eukaryotic molecular biology. Single-celled organisms like bacteria or blue-green algae that do not have nucleuses in their cells, and then all other life forms whose biological cells have a nucleus. In 1983, it was outrageous to write a single book having both modes and both forms of life together. And he's saying now in 1997, now it seems self-evident that analogous approaches can be applied successfully to a variety of organisms, and that information from bacteria, yeasts, plants, and animals can be integrated into a coherent view of the operation of genes, vindicating Monod's, Jacques Monod, view many years ago that what is true of E. coli bacteria, the bacteria that help digestion in your stomach, is also true of elephants. Jacques Monod, this was a commemorative volume of essays on him, was one of the first to really understand, he was the founder of molecular biology, that it isn't just biology. It isn't just that there is genetic material. It's that the genetic material is actually a supermolecule, like DNA, a nucleic acid, or RNA. That these nucleic acid molecules are able to create, not just to replicate, but to create all the other molecular structures that go to making up life forms of whatever kind, of all kinds. This was something that was coming to pass, especially in the early 1920s, when the University of Chicago science course had gone through many developments and become quite sophisticated. Einstein not only had brought out in 1905 his early specific theory of relativity, but by the early 1920s, he brought out the general theory of relativity. And it meant that the language of creative mathematics, showing that the universe is extraordinarily real, different from all classic presentations of it, that Barbara Mcclintock began her work in genetics. One thing that fascinated her, she was taken with the fact that her particular way of working was suited for limiting herself to a specific genetic problem, and she chose for her subject, because she had at Cornell taken courses in botany from someone that she really liked, and they cared to give her extra courses. So on Saturdays, she would have an extra course in botany at Cornell. So she began to experiment with Indian corn with maize. Now maize, genetically, as a plant, has only 10 chromosomes. Human beings have 22. What is difficult to understand was just at the moment that she was being born was the recovery of the original genetic experiments that had been done by a monk in the Czech, what is today the Czech Republic. His name was Gregor Mendel. And Gregor Mendel is the first geneticist. This is a biography of him published by Oxford University Press. In the little monastery that he was at, he made a little garden plot out in the courtyard, and he raised things like sweet peas. And he kept detailed notes, and he's the first one to understand that there has to be a carrier that is shared, paired, tuned, synergized, passed on, and his work with red sweet peas, white sweet peas. You cross them, you get some pinks, you get a red, you get a white. There are laws, genetic laws working here. And about that time, instead of sweet peas, Barbara Mcclintock began raising corn, especially Indian corn, maize, because it has a very distinctive quality to it. One thing about Indian corn is its patterning. This is a couple of sentences from a biography of Barbara Mcclintock called The Tangled Field. This is her cornfields, and for 50 years, like an ancient Paleolithic shamaness, she tended her cornfields like an old ancient wisdom corn mother until she understood. And she understood in a way that no one ever before her had understood. She could sit quietly alone, not only for hour upon hour, but day upon day, year upon year, decade upon decade, and her yoga penetrated through. And she began, like a very good mother, to be able to tell her children apart. She was the first human being to ever know why this chromosome is different from this one, because they all look the same to everyone else. But to her, she began to be able to identify each of the 10 chromosomes of corn individually, and saw that there are Mendel combinations of these chromosomes that produce the variety of Indian corn. Here is a couple of sentences, chapter 4, called Pattern. Pattern. At first glance, the colors on an ear of Thanksgiving corn, Halloween Thanksgiving corn, you can find it in any supermarket. It seems chaotic, the colors of the kernels, but a closer look reveals regularities. There may be 4 kinds of kernels: solid red, solid purple, solid yellow, and variegated. Now, if you know a little bit about Southwest American Indian symbolism, you recognize that these are the colors of the sacred quaternary, the 4 directions: red, purple, yellow, and then the variegated is usually presented as white. And what is esoteric about it is that if you take white natural light and you put it through a prism, it will show you that white light is actually a spectrum, a rainbow spectrum. That's what it's made of. That if you are able to see that this square, this frame of reference, this universal picture of reality structurally, is that one part of it is only revealed in its further complexity by a kind of a lensing through a prism of its apparent appearance into its actual structural appearance. Barbara Mcclintock was able to do this with chromosomes, and she's the first one to understand it. And she worked with these special Indian corn chromosomes, and after about 10 years, she was the first to notice that the genes carried by the chromosomes sometimes do not stay in the classic position that they were before, that they jump around. Her observation was dismissed by everyone in the world. This crazy woman spends every damn day in her cornfields all the time, or in the lab staring at them for hours after hours. What is she doing? She's saying that genes move around on the chromosomes. Everyone knows that when God does something, it stays put. But Barbara Mcclintock said, I can see it. And so her papers came out, and now they're collected together. One of the most expensive science books in the world. Cost you $600 or $700 to get a copy of this. It's out of print. Genes and Organisms. Another of her collections is called the Dynamic Genome. It doesn't just stay there where it's put. It is placed into play, and that life in reality plays with variety in freedom. That life is not stamped out by some kind of predisposed medieval Greek, Roman cookie cutter, but that life is real because it plays creatively all the time. And that we are really not the result of an impress, but we are the jewel-like prism of a whole undiscovered capacity to not just be who we are, but to be who we would like to be. And this elf, extraordinarily, This is a page from Genes 6. This is a page that shows how chromosomes, when they come into interplay to make a new cell, do something which we have explored in our learning consistently and constantly. And that is, there is a paired quality. We always take pairs and we run the pairs through a series of dynamics, and then we allow the pairs in that dynamic to come into a cinching, into a polarity, so that the phases of our learning are actually paired. We take a dynamic phase like nature, and then we take a form phase like ritual existence, and we put them together. We take a dynamic phase like myth, mythic experience, and the way in which the form of the symbolic mind is paired with that. We put them together. Then we put those two pairs together to make a frame of reference. Then we understood that that frame of reference doesn't end with the mind, that the mind has a transformative capacity. And what comes out of the transformed mind, if it's not closed off presumptively by having your wings clipped by all kinds of inculcated instruction that says to you, this is the way it is. If you want to get a job, you better toe those lines. But the mind sometimes gets glimpses beyond itself. It will dream, it will have insights, it will have moments of brilliant flashes of aha. It will have the capacity to sometimes look almost magically at something and to know it before it happens, or to know what someone is thinking about and you didn't hear them, but you know. All of these capacities are capacities of consciousness. And visionary consciousness is a process, and the form that comes out of it is the artistic person, who is not a mind, who is not an existential body, but who is very real as a spirit form. Now you have something which is like classic esoteric wisdom. There are bodies that have an awareness kinesthetically. There are minds that have a thought realization, and then there are spirits that have a completely different mode of consciousness. And because they have this mode of consciousness which carries the dynamic and the form through three different levels, a fourth phase comes out of that. A fourth quality of dynamic and a fourth quality of form. And what it comes out as the transform of visionary consciousness into historical consciousness. And historical consciousness has a very special form that comes out. It's called the cosmos. It's no longer a one place, it's an everything place. It will be as mysterious as it wants to be. The old form in the Torah 3,000 years ago, Moses at the burning bush, God is telling him, you go down and you tell people, these are my commandments. He says, well, who shall I say sent me? And it's there in a very curious way in the ancient Hebrew. It can be translated as, tell them, I am that I am. But the same words given a different inflection pronounce in translation, tell them I will be who I will be. Unlimited, infinite variety and possibilities. Barbara Mcclintock is one of the world's great geniuses. She found that the genetic forms play, and they not only change positions, they're now called transposons. There's a whole chapter on transposons in here. They not only change position, but the position adds a dimension to its structure and its form. so that when one comes to a cosmic form of reality, it is scintillating like a spiritual fire. Let's take a break. Let's come back to what it is that we're doing, what it is that we're pursuing. And we're pursuing a very complex, the frequency of reality. It is not at all appreciable if you try to cut it up. And part of the difficulty for the last 3,000 years is that as human life has become more dense and complex and shifted from a tribal basis with cultures that are natural, they're healthy when culture and nature happen together. But when human populations get large enough, and you begin to have social forms that are larger than tribal gatherings, larger than cultural geographical areas. Now you have multicultures and dozens, if not scores, of different tribes, and the interpenetration becomes complex enough to have a social form called a civilization. And in order to sustain a civilization, there was traditionally the solution that one needs to take just the essential bits from the cultures and from nature and put those essential bits together mentally. And so it was the mental categorization that mimicked the old cultural tribal ways and blew it up into large size that produced the flaws that made civilizations impossible to sustain. Every civilization ever developed on this planet died, ended. We live in a generation period where there is no viable civilization anywhere on the planet. So that the ancient challenge of trying to figure out how are we going to make a new civilization is with us again. And this is why our time is so much like other areas in history around the planet whenever men and women faced a similar kind of a challenge and task. Our kind of challenges are very familiar to people who know these historical eras. We have a lot of similarities and characteristics in many ways to the Renaissance 500 years ago, when they were trying to make a new Renaissance rebirth of classical antiquity and bring it out into the new realities of the 1400s. Of the 1500s. And for the first time since classical times, you had individuals who were as complex as classical individuals used to be. You had someone like a Leonardo da Vinci or a Michelangelo who were as complex as people in classical times like Plato or Aristotle. And we today, in our time, have had individuals who are as complex as Da Vinci or Aristotle ever were. Einstein is a great case in point. Niels Bohr, who we paired with him, great case in point. Barbara Mcclintock as well. What we're trying to appreciate is that the next civilization, if it is patterned on any of the old presuppositions, because of the speed up of time, because of the speed up of events, will not last for 1,000 years will not last for a couple of hundred years, will last for about one generation, and it too will crumble, will be subject to the built-in flaw that's there in every other civilization that the planet has had. Which means that it's an impossible task unless you can step outside of the presuppositions that were there that are flawed. So the problem is, how can you get primordial enough to start from scratch and mature through whatever you have to mature through without going into the flawed mistakes that are not only there in identifiable ways, but are there in unidentifiable ways and yet are still operative, are still there. That while there are presumptions that the mind makes in its flawed thinking, there are prejudices that the skewed heart makes in its feelings. So that not only is intelligence sabotaged by false ideologies, but human experience is sabotaged by prejudiced qualities of limited humanity. And not just limited humanity, but the unappreciation of other life forms. Not just be kind to people, or kind to pet animals, or kind to wild animals, kind to plants, kind to the bacteria, kind to all kinds of organic possibilities. There is a deep, wrong-hearted prejudice and a deep-seated intellectual ideology projection that almost forbid us from being able to deal with this. We can immerse ourselves into nature for a little while, get ourselves primordial again, walk alongside the ocean and just get beach open, or go into the mountains or into the deserts to get back into touch with nature. And one can get into touch, and then more and more you notice that as you come back into town, back into the city, back into what is the shards of a civilization, more and more it becomes almost offensive to come back. You can get purified enough so that you become super sensitive, and coming back, you notice what you had not noticed before because it was so omnipresent and seemingly ambivalent that you wouldn't know. I had the experience of leaving the United States under extreme self-exile duress after the 10 years of anti-war protests in the 60s. I went to teach in Canada. That's enough of this. And I didn't come back to the United States for 3 years. And I made a visit. And I came back in the most calm, unobtrusive way imaginable. I drove back into the United States at the top of Idaho, in between British Columbia and Idaho, where the only thing that's there is a customs station on either side of, they're in the same forest, alongside the same lake. On one side is Canada, the other the United States. There's no difference whatsoever until you cross the line. I stopped the car. I thought there's something wrong. What in the world is going on here? And I stepped outside of the car, and I could feel like I had entered a pressure cooker. There was a palpable psychic, physiological, kinesthetic sense of steamy pressure. So I thought, this is interesting. I'm a professor of humanities. So I thought, I'm going to test this. So I walked across the border, left my car, and I talked to the Canadian's custom guy, and I said, do you guys ever notice a change? He said, oh, we don't talk to them. So I walked back across the border and was almost arrested by the U.S. Customs Inspector. I was the only person there. He said, "You're illegally crossing the border." I said, "I just drove across the border. You inspected my car 5 minutes ago." He said, "You have just walked across the border." This is 1973. There are dangerous, corrosive, highly acidic qualities loose in our lives all the time. We don't pick it up until we get ourselves purified, till we get ourselves refined, till we get ourselves expanded, until we understand that there's no way to learn about reality as long as you proceed from cookie-cutter categorizations of dividing, especially education, up into subjects. You must take such and such a subject and pass such and such exams, and everything is standardized and codified. All of this is a part of the failure of those previous flawed pseudo-civilizations. None of that can be used without great caution. It's like a home where everything is high-tech and no one knows how any of this is made and works, and as soon as you go to touch any kind of button, you don't know what's going to happen from that. The same thing in our lives today. So this kind of a learning is a completely different kind of learning, but it is so new and so radically different that hardly anyone can appreciate what it is. And we'll come for one presentation and that'll be it, or come for a little while and that'll be it. Whereas it takes a cycle to go through the natural integral, starting with nature and bringing ourselves all the way up to the sophistication of the mind where it can realize itself, and then to take that through a whole ecology of transforms, not just one, but a whole ecology of transforms, and take that mind and make it transparent so that the symbols don't just look back and integrate, but they clarify themselves transparently and they allow you to look through the mind like an open window to see the context of where all of this really is, and that the context is what used to be called magical. The universe may be a one place, but the cosmos is a magical infinity of all kinds of places, even forms of things unknown. And the most unknown is the time dimension, subject-wise, that used to be called the future. The future is really the unknown. And about 110 years ago, one of the most perspicacious books ever published was concerned with time. It was called The Time Machine by H.G. Wells. And in The Time Machine, as we talked about a couple of weeks ago, for the very first time, you had a self-educated character like H.G. Wells. Came from a perfect, ordinary English family, nothing distinguished, educated himself reading in public libraries, was lucky enough to hear a couple of people that were famous talk, and largely educated himself. He was a journalist, a reporter. Then he discovered that he could write exciting stories like The Time Machine, The War of the Worlds, The Island of Dr. Moreau. And year after year, H.G. Wells became one of the most famous writers and creating a whole new genre called science fiction. But he was also the discoverer of the future. Yeah, and not just that, he wrote a little book that was published originally in 1902 and then put out into a very nice edition in 1913 called The Discovery of the Future, published in London. It's very rare, this little book. He says there are two kinds of minds loose. He says there is a legal mind that says that you need to do it the way laws, the way rules, the way categories, the way subjects say you must. And then there's the creative mind. Things have been, says the legal mind, and so we are here. The creative mind says we are here because things have yet to be. Now, I do not wish to suggest that the great mass of people belong to either of these two types. Indeed, I speak of them as two distinct and distinguishable types, mainly for convenience, and in order to accentuate their distinction, there are probably very few people who brood constantly upon the past without any thought of the future at all. And there are probably scarcely any who live and think consistently in relation to the future. The great mass of people occupy an intermediate, a big gray area, an intermediate position between these extremes. They pass daily and hourly from the passive mood to the active, to see this thing in relation to its associations, that thing in relation to its consequences. They do not even suspect that they are using two distinct methods in their mind. One of the qualities that came out after 50 years of poignant, conscious life, the last book that H.G. Wells published in 1945, Mind at the End of Its Tether. Yeah. He was told he didn't have much longer to live. He better write his last work. Chapter 1, it's only about 50 pages long. Chapter 1 is called The End Closes In Upon Mind. And the theme of it is that the mind is at the end of the tether. Now, tether is a term that's used in taming a horse. And the way you tame a horse is you tie a rope around its neck, and with the other end, you tie it to a stake in the ground. And that rope then is the tether. And the wild horse will move every which way and will come to a distance where the tether pulls taut and stops it. And after a while, all by itself, with just that ritual condition imposed upon it, the horse becomes tame because it understands it cannot go outside of the circle of its wildness without the tether stopping it. And so now the horse is rideable with reins because it's always within the circle of that tether, and the reins have tamed it, and you can move that circle anywhere that the rider wants to go, but the horse never leaves its tether in the form of the reins. It's called conditioning. Every human being on this planet is overconditioned. Automatons. In every deep sense of the word. And what is scary most for them is not parachuting and plunging several miles, is not facing death, it's facing the new, the unknown. So that one of the things that has developed over the last century is science fiction, and that's why, along with Barbara Mcclintock, we're taking one of the world's great living science fiction writers, Nancy Kress, who's really somebody, who's really poignant. And we're taking one of her novels called Beggars in Spain. It's about a genetic mutation, just one. It's removing a particular tether from the nature of man that has been there since the beginning. And the tether that's removed is the need for sleep. And so she writes a whole novel on the development of this human mutation, the Sleepless. And you would think, well, all right, that's nice. That doesn't go very far. It goes increasingly farther, because what has been removed is not just the need for sleep, but the inculcation of tethering itself. Now, these people realize that they are not just different from other people, they are totally free from the conditioned presupposition and prejudices of other human beings, but they are now part of the unknown. They're part of the over-challenging new. They're part of the dangerous future, and so increasingly they are seen to be like Frankensteins. So they learn that they have to band together to protect themselves. This is not a very nice world. If everyone else considers you as different and only several hundred or several thousand of you are very similar, and so they have to find and build their own retreat called sanctuary. And it goes on from there. So one of the collections of her early stories is called The Aliens of Earth. That the biggest aliens are a new kind of humanity who are untethered. And that the whole development of science fiction has been to expand and explore and open up possibilities, and it speaks not to culture, not even to civilization, but to all kinds of different possibilities of life forms, interstellar civilizations, intergalactic possibilities of life without any limits whatsoever on it. One of her early novels is called Brain Rose, where there's a genetic plague going on and people are being affected because they're losing their memories, their ability to remember. But that there's a special minority of people who undergo an operation to preserve their memories against the plague. And what it does is it preserves not only the possibility of remembering their memories, but of remembering their past lives. That the tether keeping them only in this mind with these memories is removed, and now this exfoliation of the full rose of all of their possibilities of being real, of all the different lives, not only that they have led, but that they could lead in the future. And so the brain rose is one of the themes. You can see Nancy Kress is really somebody. A clear inheritor of H.G. Wells. One of the triggers in all of this came in the early 1940s. And the trigger was the development of the atomic bomb. There was a concerted, cramped realization that occurred in the 1930s. One of the discoveries that came, 1932, was the discovery that, yes, there are these subatomic particles, there are electrons, light, the carrier of it is a photon, there's a nucleus with a proton. Then there was the discovery that there is a neutral form in the nucleus of the atom called the neutron. And that the neutron, like electrons or protons or photons, can be scattered by certain media, and that very slow neutrons can penetrate the atom, can penetrate into the nucleus, and change it. Because it's not positive or negative, it's not deflected, it goes right into the nucleus. It's like the slower version. It doesn't just work with staying in its regular configuration, but will penetrate, and when it does, the atom itself will split. So that there's such a thing as atomic fission for the first time, which means that atomic fission is an untethering of the elemental stuff of the universe. And what comes out of this is a release from the structure of a great portion of its energy. But the math was scary. And the math, after a generation or two from Einstein, by the early 1940s, the math was very scary. Because in one way you could read it out that the simulation would show that there is no end to the explosion that would happen. And that if you set off an atomic bomb, it would ignite the nitrogen atmosphere of the Earth, and the entire Earth would be incinerated. It was there in the math as a possibility. Two individuals made the decision. One of them was a man, his name was Arthur Holly Compton. He's the first one to discover the Compton effect of the slowing down of the scattering of electrons, and worked with cosmic rays, won the Nobel Prize for Physics in 1927. A regular sort of a character, a Midwestern boy who turned out to be one of the world's great geniuses, and also was extremely involved in world peace movements, the World Brotherhood. He was a Presbyterian elder who lectured at the Jewish Theological Seminary. He was always the first to sign petitions to humanize the sciences. He used to spend his summer vacations in a northern Michigan place called Lake Otsego. He had a cabin there, and he had been going there for 50 years in the summer. And he had a visitor in early 1942 who was the director of the Manhattan Project to make the atomic bomb, Robert Oppenheimer, who in order to get to Lake Otsego had to take little trains because it's a couple hundred miles north of Detroit. It's about 100 miles north of where I was a boy in Michigan. And it happened when I was about 4 years old. The discussion that Oppenheimer and Compton had together on the early morning dawn on the shores of Lake Otsego was to go back over the math and to see, is there any possibility that it would work out this way? And the two of them were brilliant enough to discover that it would not work out that way, and therefore an atomic fission was possible, because a trial example in a secret laboratory had already been done. And the laboratory was perfectly hidden. It was hidden under the football stadium in Chicago on the University of Chicago campus, where Compton had been a professor since 1923 at the University of Chicago, along with several very brilliant Europeans who had fled the fascist takeover of Europe, and one of them was an Italian named Enrico Fermi. And when you had people like Oppenheimer and Fermi and Compton all working together intently, you had the most brilliant brain trust probably ever assembled on the planet. I was a little boy, 4 years old, playing in the living room. My mother was ironing at an ironing board and the radio was on. And I remember stopping playing with my little trucks because the radio had a report about the possibilities of an atomic explosion being tested that could ignite the atmosphere of the planet. I remember distinctly getting this eerie quality of feeling. So I stopped playing and I went over to the ironing board, which was taller than me. I was only a little 4-year-old. And I asked my mother what a chain reaction was. And she knew nothing about it, had never heard of it. I will never forget realizing that there were dangers so real in the world that my parents didn't even know about. We live in a world today that is just inches away from a conflagration of nuclear proportions. The Cold War was never a danger like it is today. When you have a dozen, soon to be about 20 nations with the old prejudices, the old ideologies in full force, fearing the future, fearing the new, fearing any kind of variety, you have a situation that is built in. Either the mind has to be untethered or civilization is through. But the only way to untether it is to have a learning, an education that is not bound to subjects, is not commandeered by doctrines, is not determined by ideological mentalities whatsoever, is not subject to the ritual demands of previous semi-successful rules, laws, regulations, etc. One of the things that we have discovered in our learning is that there is a vast difference between the integral cycle and the differential ecology. And the difference is a transform that is graphic. In the old integral cycle, which can be symbolized by a circle, there is always a center to that circle. The integrity of that circle is that there is a center to it. So that nature centers all the time, over and over again. And that the mind, as the highest integral of the universe, has a center. But that center point has a transform capacity when it is subjected to a kind of a magnetic quality that's larger than its natural integral magnetic. The center changes and becomes an axis of a magnetic field. So instead of a point, you have a pivot. Instead of a circle, now you have a magnetic sphere, which will have poles and will have an equatorial median point, and that's exactly what one finds in cell division. In cell division, chromosomes pair themselves, and when the mother and the father both contribute a chromosome together, there is enlargement, a shortening and a fattening of the chromosomes in a certain phase, and then when they enrich to a certain point, the cell generates, not staying in its center, but generates a magnetic axis, so that the chromosomes now occupy an equanimity on the equator of that magnetic sphere. And then they split. The two pairs become two other pairs that migrate along the magnetic field because of the axial pivot in the cell, and they will go to the poles, and when they do, you have two new chromosomes at each side, and that's how the cell will divide and make now two cells, each one having those chromosomes. So that life itself works by taking a transform of the point of the circle into the pivot of its fertile sphere. Our education does the same. Our learning does the same. The whole first year is to achieve the ambit complete of the cycle and to see all the different points that are achieved and attained, and they're all quite real. They are the point. One can get the point of what this action is all about. One can get the point of what this idea is all about. You can get the point of experience. And when you arrange all of these points together, they generate a possible gestalt that becomes the set that now aligns itself as the pivot. So that the pivot is not just the point of the mind, but it's the entire set of all the points that you had achieved. And if you have achieved a great many different points, the pivot will be very strong, very rich, very complex. The more nutritive that you put in, the more points of the more circles that you have been able to integrate, the more the layering, the more of the complexity, so that the pivot now is not just a weak little pivot of doing just little tiny pirouettes, but it becomes like a grand, masterful ballerina who is able to do incredible moves. And out of this, one generates the sphere of consciousness that's very strong. It's not just a little moment of insight. It's not just a little quality of penetration, but is an enormous field of a dynamic which is visionary on world-class scale. Now, when you have a population of people who are learned in this way by phases rather than by subjects, they are not limited by points, but are able to transform all the points into many kinds of pivots. And now one has a whole new kind of humanity, stronger than any science fiction, more poignant than any tribe ever could be, or any culture ever could be, or any civilization before, to go where no man has gone before, boldly. The next civilization will be the size of the whole star system, minimally. So the best name for it is stellar civilization. And within the next 200 years, the next 5 generations will make that star system civilization. This may not be the only learning. There may be other possibilities. But after 40 years of working at this will work. And it's not incumbent of whether it is popular or understood or promoted. It works. It does its stuff. And there is a noticeable, palpable, pivotal transform that happens. And it happens in 2 distinct modes. One is a transform by fermentation, classically said, making the water into wine. The second is a transformation of distillation, of making the wine into cognac. Art is the wine of consciousness, and science is the cognac, and they're related. In the Renaissance, for the first time, you had non-subject places that you could learn. They were called universities that didn't just study subjects like theology or law or medicine, but you studied the arts and sciences together. And for the first time, you had this conscious regard that there is such a thing as a Renaissance man or a Renaissance woman who can do maybe 40 things well. Why do they have to be a specialist and do one thing only? I guess the archetypal figure is Leonardo da Vinci, who literally could do almost anything, whose notebooks show he was designing submarines and airplanes 500 years before they were built. It is extremely important not to look around and see how few can get this because it is new. It's extremely important simply to do it. And as you do it and carry through, this is formed in such a way, the pairings, the possibilities, so that one comes out with a completely new, not just set of capacities, but a new range of reality. We're going to, next week, take a look at Linus Pauling, who was the great developer of how to translate the developments of math and physics from quantum mechanics into chemistry. He wrote the first textbook in 1935, Introduction to Quantum Mechanics, with applications to chemistry. And it was the first time that anybody had taken a limited science and had expanded it so that it completely fit together with a completely different science, and they were seen together. Pauling did this at Caltech, just about 15 miles from here. And he did it 70 years ago. More next week.